So this is a topic that I normally have not been taking at this level. I normally take it at the advanced level, but since several of the concepts have already been introduced and I kind of have referred to it earlier, I will go ahead and do it, at the Bio 201 level anyway. So if any of you end up taking my advanced class 2 years or 3 years from now, please remind me that I taught this thing to you guys at this level. Okay, I'll probably obviously at the higher level now make it slightly more complex, but still. And that topic is aging. So what do you guys understand by aging? It's a very commonly used term. What's your idea?
Cell division starts stopping, so you can't repair organs.
That you are giving me a mechanistic, reason for it. But what is it? What do you mean when you say that somebody has aged?
They have progressed in their life cycle.
Okay, so when you are born, as a baby of about this size and you are slightly larger now, you have definitely progressed in your life cycle. So have you aged?
I would say to some extent. Like I think Akash's definition is a lot more clean.
That's not a definition. That is just a mechanistic basis of it.
Yeah, I mean that.
If I say what is death and you say putting a bullet to my head, then putting a bullet to my head will lead to death, but putting a bullet to my head is not death. That's the difference. Anyway, go on.
So like I think there is some period of growth following which aging happens.
And therefore
so some
aging is
sort of
defined.
degeneration over time.
Right. So aging is intimately related to the concept of degeneration. Degeneration related to some kind of a baseline. Otherwise, as I said, the initial part of life, when let's say you are going from a zygote to offspring, or you are going from, let's say, just born to adulthood, that part is typically not considered in terms of aging. So yeah, this is simple. So what exactly happens during aging? So there are several factors that decline over time. So for example, this is in very anthropocentric way of looking at it. So things like personality, don't ask me what is the definition of it. They more or less stay constant. However, for most other things, they start declining pretty early on. Okay. And this age dependent decline is what is known as aging. Now, because of this decline in various physiological functions, evolutionarily speaking, two things happen which are of importance and evolutionarily. One is that the number of babies that you are producing, the number of offspring being produced, that keeps on going down over time. And second thing is that the survivorship, what is the probability that you survive up to that age, that keeps on going down. Okay, which you can also do a cohort study. So that is the way in which this has been presented. You take a cohort and you see what number is alive. That number is steadily going to go down. Now, this function, it can have many other shapes. So for example, in the context of humans, the function typically looks something like this. Okay, that doesn't really matter. What matters is this decline part. Somewhere or the other, there is going to be an age-dependent decline. Now, this, as I said, this is age-dependent, and this happens after a particular point in life. For different organisms, that point is at a different place. So the extreme case is with those organisms which live for one day, okay, and then die. So their entire lifespan fecundity is just concentrated on that one point, and then it is decline and zero. And on the other hand, you have something like what this human case that I showed you. So technically, it's a late life decline in individuals' fertility and probability of survivorship. Now, why is this such a big deal? It's such a big deal because psychologically very few people like looking old, and as a result, psychologically also humans have a major fear of dying, and therefore, aging is supposed to be a precursor to death, and therefore it's a trillion dollar industry all over the world. And of course, medical science, a huge part of medical science actually concentrates on problems related to aging and problems, faced by old people. So from a very economic point of view, it's a big deal. However, from a scientific point of view, it's an even bigger deal. It's a very interesting question. Why is that so? And the question is that why is it that organisms age at all? Because after all else being equal, natural selection is expected to increase the overall fitness of organisms. Now, any decline in survivorship, any decline in fecundity is obviously a failure of natural selection. So in some sense, why is natural selection failing? Why is it that, although the aging reduces fitness, why is it that evolution has not been able to get rid of aging? And since both these traits that we are talking about, fertility and survivorship, these are like core of the core fitness related traits. So obviously for any organism, the selection pressure on these traits is expected to be very high. So why is it that evolution has not been able to get rid of aging even after millions and millions of years of selection across so many organisms? And this happens to be one of the major unanswered questions in biology. Let me put it this way, there are several camps which think that they have answered the questions. For example, evolutionary biologists are completely convinced that they have answered the question. Molecular biologists are also equally convinced that they have answered the question, and yet somehow, people are still trying to figure out what the deal is in the context of this particular thing. So before we begin, why do you think aging happens? As I said, it's not entirely settled, but what is your guess on it?
So isn't the question irrelevant here? Because aging does not apply to populations, right? Aging is for individuals. But natural selection acts on populations, right? So throughout the life of an individual, microevolution does not increase the individual's fitness, right? So, but the individual ages, no?
No. The individual ages, but suppose there are two organisms, okay? One of them is, let's say, dying at the age of 10 and producing only 2 babies, and the other is dying at the age of 20 and producing on an average 4 babies. Correct? So, on an average, the population's fitness is going to increase because these guys who have, who live longer and live behind both more babies, they are going to increase, and their frequency in the population is going to increase. Correct?
Yes, sir.
So if individual level pay, you can increase the fitness, ultimately that is going to benefit the population, or that is going to increase the fitness of the population, let me put it that way. So that natural selection should be able to do. Why is it not doing it?
Sir, I had a very naive question. So in the population dynamics, when we did that, we studied the agent-based models, right? There, when you had only rabbit and the grass was finite, say, then if the rabbit population exploded, then they eventually died out, right?
Correct.
And is that related to why aging is required in a sense?
So what you are saying is that aging is required for the good of the population itself. Because
yes.
if there is no aging, then organisms are going to just take over the entire resources, correct?
Yes, and eventually die out because resources are scarce.
Correct. But think about it. Suppose there is, let's say, one species which doesn't obey this dictum. What you are giving is a very group selection argument. Okay, that what is better for the sake of the group is what prevails. However, the major problem with the group selection argument always is that if everybody in the group is evolutionarily speaking doing that, but there are some cheaters who are not thinking about it and they are increasing their own fitness.
The
So there is
cheaters
no
will greatly benefit in a sense.
there is no way to check them. There is no
Yeah,
mechanism to check them.
Correct.
Sir,
Yeah, Molo?
when you say that why hasn't aging been rooted out by evolution, hasn't that happened in some species? I mean, like those trees that live for 4,000, 5,000 plus years, do we see a slow deterioration in fitness over their lifespan? Or when you look at things like Hydra, which can reverse their aging
The
process.
problem with the sequoias that you are talking about is that their entire span is much larger. Okay. So then one has to study that over that time scale. We have not been able to study that over that time scale. For obvious reasons, right?
I mean, you could compare the mean fitness at two different ages. Like,
For which two ages are you going to compare? So
you
if I
can
take
young ones and old ones. You don't need to do a necessarily like cohort study. थोड़ी ना करनी है.
हाँ, पर सर्वाइवरशिप और फेकंडिटी के लिए
Okay, yeah.
such long species like that क्या बने किस स्केल पे स्टडी करो?
Okay,
200 साल तो चाहिए ना?
हाँ, true.
Right.
So does that also apply to like animals like jellyfish, for which statements have been made that jellyfish are immortal and all that?
See, the point is that their immortality, as I'm not entirely sure where that statement comes from, because I think in their case they are more agglomeration of organisms, right? And therefore they are able to replace. That's my understanding over there.
Right. So like how we say single cells are immortal in the sense they keep on dividing. So because these are just aggregations.
The problem over there is that there the concept of an organism itself becomes undefined. So when one bacteria has become two bacteria, what do you say? I can look at it one way and say that the original bacteria no longer exists.
Yeah.
Okay. And in that sense, well, it has died. So their reproduction and death are one and the same in some sense.
Yeah.
Sir,
but jellyfish
are
are
we
also like unique singular entities, right? That they have their own physiology, nervous systems and so on.
Yes, but it is very loose, right? And then they end up adding and subtracting, correct? That's my understanding. I haven't really looked at the jellyfish problem. Okay,
Yeah,
jellyfish, I will keep my mouth shut on jellyfish because I'm still not entirely sure about how jellyfishes are considered immortal. The asexual ones, I know that doesn't work because of that philosophical issue about reproduction equal to death. So anyway,
sir,
are we
making a distinction between not aging and immortality?
That is why very strictly defining aging as this. Okay. I'm defining aging as a late life decline in fertility and survivorship. All right. So if you are able to give me an organism which is not doing this, then I will say it's not aging. And in that sense, a bacteria which is not showing these two things, you can say that it is not aging. So the definition of aging is independent of the definition of dying. Do you see what I mean over here? And the problem only happens when you confound aging and dying.
Sir, if we go back to your first or second lecture when we did the survivorship curves, weren't there survivorship curves that did show, no such late life decline in
How?
No.
No, how come?
Wasn't there didn't one of the survivorship curves essentially have like very low, like the vast majority of mortality in a very young stage, and
yes,
then
but even
constant after that?
That is the rate at which the death is happening, and even in those cases, the decline happens early on, and then the rate of decline slows down. Okay,
So does the
But
rate of decline slow down and then again increase at some point, or does it just stay slowed down? Because if it doesn't stay slowed down, it's not really a late life. Unless you say aging is as soon as you stop being a juvenile. Or like, wait, no, that wouldn't work either.
that will not work. Yeah.
So,
So see, it's a little bit more complex than that. Okay. So that is why I'm saying let's just stick to that definition that I gave, because otherwise defining aging becomes very problematic. And okay, I had no plans of covering it over here, but essentially one of the major discoveries or insights in the field of aging is that aging actually stops beyond a certain point. Okay, you have the kind of mortality plateau that you are talking about, that late life mortality plateau, it has become a defining feature of our understanding of aging these days. It's not a steady decline as one would believe from this first graph that I showed you guys. Okay, in this particular case, if you look at it, there is almost steady decline in all these cases. However, one of the major insights is that for many traits, it's actually going to do this. Okay, a late life mortality plateau, a late life plateau. Okay.
yeah, okay.
Yeah, but वो उसमें जाने से पहले we have to figure out how we are going there. So this definitional things will not work out in the sense that okay, I'm not entirely sure how I reached here, but I don't see the problem in some sense. Your definitions of aging, as long as you take the definition that I give, it should not lead to an issue. It should not lead to conundrums.
I just meant that if the mortality is very high initially and then it decreases, right, and then it stays at a low value, then you're not seeing an increase in mortality and therefore a decrease in survivorship in the late life.
But I said that for every population, that thing is going to happen at a different point, right?
Okay.
So the aging point, you can take the early part, right? When the steep decline has happened.
The steep decline in mortality, or
Steep decline in survivorship.
so if what I'm saying is, if the most vulnerable point is at the point of their birth itself and everything after that is better, then
Yes,
it's
that's a very nice philosophical stance. And the point that we are trying to make is that typically what happens is, if you think in terms of fitness, then up to a point, it's either steady or very slowly declining, and then there is a precipitous decline at one point.
yeah. So that's what I was saying. I don't remember the survivorship curves of those species reflecting that kind of
Which
precipitous
one are
mortality.
you talking about?
That is
Are
what
you
I'm trying to
talking
figure.
H3? The one that looked like this? The one that looked like this?
Yes, yes, yes.
Right. So in these particular cases, probably somewhere around this inflection point would be my guess.
Okay.
It becomes a lot less obvious into, I completely concede that point, but the definition doesn't die because of that.
Okay.
Okay.
From
Okay.
early ages.
Sorry. Okay. So I don't think we have time left after this. So we will start in the next class with what is meant, why is it that we think aging ends up happening. Cool. So I'm going to stop the recording now. Yeah. So the class, this is coming to mind. Good.